All right, I'm John Nash with Freedom Technologies. I've been invited by SC Squared to talk about Next Generation Firewalls. So what we're going to try and do here is review the technology foundations, understand the full complement of features, and look at the risk management perspective, because at the end of the day, it's not just about your firewall. It is about how are you managing risk, right? We're not here to select a product. What is the best? I want to avoid that concept, because at the end of the day, it's what's the best product for your organization, and not be the best product for another organization. So we're not here to endorse any product. We're here to help educate you on what are the steps you go through when you evaluate a new technology, specifically firewall. All right. As I mentioned, some contributors, resources, product literature. I went to a lot of different vendor websites. NSS Labs was kind enough to provide some normally paid material. Gartner reports, as you wouldn't know, if you go to most vendors, they'll have a link to their Gartner report, which they think shows their dealio in the best, most favorable light. So you can get a lot of that stuff free. And then my firsthand experience in firewalls. And whenever possible, we'll try to be objective here. So security is complex. We're working in a rapidly evolving threat landscape. And vendors are working strongly to differentiate themselves. Security is infusing itself into all intelligent devices. So gone are the days when you just put a firewall at the perimeter of your network and I'm protected. I've got my inside trusted. In fact, I don't like that word trusted network, because really no network should be trusted. Everything should be protected, but you assess the trust level, and we'll get into that. So in addition to buying whatever device you want that you think is going to solve your problem, you have to have the skills to basically manage that technology. And that was touched on by some of our earlier presenters. So that's a very salient point. So a security architect needs to be a generalist. And what do I mean by that? So much like the medical community, we've seen cyber evolve into various specialties. I've got this certification, I've got that certification. I don't work on that type of system, I work on this one. But at the end of the day, if you're a security architect, you have to have a combination of skills that might cross over all areas. The day may come and you have to start doing some programming, scripting. Does that mean you're a full-fledged web app developer? No. But you need to understand how those things work, especially if you're trying to troubleshoot applications or automate a particular task. And for a lot of the advanced features of these firewalls, they expect you to do scripting or the integration. So in addition, you've got to understand interoperability. You've got to be a business analyst. You have to understand, what's my organization trying to accomplish? And then I've got to speak in a business analyst language if I'm talking to the C-levels to justify my budget or a particular initiative. And social engineer, so this is a particular good one. You have to understand, because basically social engineering is a tool that's being targeted for your user base. So you have to understand how that's working so you can defend against it. And design your systems to support that initiative. And then finally, an advocate for change. So because we live in a rapidly evolving threat landscape, you can't just sit still and wait for the problem to come to your doorstep. You have to anticipate what the next challenge is and start to prepare for that. Okay, the death of the firewall has been greatly exaggerated. The common conventional thought is that the days of the firewalls are numbered, and that actually may be true. And as far as the physical firewall that you put in your rack that sits at the perimeter of your network. So I would say yes and no. Gartner's saying that by 2022, there's going to be an increase in spending for firewall-related technologies. After that point, they see that dropping off as more organizations are moving that intelligence and that capability into the cloud, because for scale of economy, collapse that technology, and your provider maybe is better able to manage that. I would argue it doesn't really matter where that physical box is, and whether it is a physical box, or if that intelligence is in the cloud. At the end of the day, your management skills and the problems you're trying to solve are the same. So All right, so we've got some statistics up here. 30% growth rate through 2017, that was last year. Gartner forecasts a 9% through 2020 to a total market of 14 billion. So this was interesting. Firewall refreshes typically go in a 5-year cycle. Well, it makes sense. It's such a difficult implementation to rip out your entire firewall infrastructure. We have a question. Let's go ahead. That's a great question. So he asked, what do I mean by the firewall? So by the firewall in this context, I mean the physical box that you put in your MDF at the edge of that's the first connection to your ISP. So when we say firewall, we're thinking about that box. When we talk about next generation firewalls or your security ecosystem, now we're talking about all the software and the tools with it and surround it. So we're kind of giving away the lead here, but the takeaway is that there's going to be so much intelligence in your network that one physical box in your MDF ISP handoff isn't really going to be that important, whether it's there or in the cloud. So it may disappear and go into the cloud. That's the takeaway. And then one thing Gartner did call out is that next generation firewall is kind of a buzzword that a lot of vendors throw around, and it's led to confusion, and one of the reasons that we're trying to touch on that with this talk. But they prefer the term enterprise firewalls. Those two things have become synonymous. So for the purpose of this, you could use either one. All right. So what we're going to touch on is basically a market overview. We're going to get a little technical. We're going to get into some protocols, how they work. Some of that's just foundation stuff. If you're technical, forgive me. Some people here may want that information. Internet works, a little bit of history there. I'm a history buff, so indulge me there, but I think it's valuable to kind of see the progression of where we've come from. We're going to do a deep dive, not so much in how encryption works, but what are the different types of standards and why they're important when you're talking about firewalls. It used to be encryption was separate from your firewall conversation. Now they're pretty tied together. And the general threat landscape, nothing new for this group, but we'll talk about some resources that kind of speak there in the trends. And vulnerability databases. So I'm sure a lot of people here normally do vulnerability scans. You might have Rapid7, Qualys, Tenable, whatever your favorite vendor is. But there's a lot of feeds that tie into firewalls. Firewalls can ingest that threat intelligence from third-party sources as well as the vendor in question, and combine that to make better decisions about how to protect you from threats. So we'll talk about some dynamics there. What is a firewall? Define that. Next generation, how they differentiate themselves, and review some independent reports, and vendor comparisons. So I might get in a little bit of trouble here if we've got anybody from Cisco or other big names. But I'm not going to pull any punches. So at the end of the day, this is pulled from NS Labs and objective sources, so I think there's some value to reviewing that. Okay, what is a firewall? Pretty basic stuff. First of all, it separates security zones. So if you've got traffic going between a DMZ or a protected network, that should be going through some intelligent security device that can police that traffic. It enforces policies and allows you to administer what traffic is allowed to go. It adds security. It should make you more secure because you have that device. And then polices traffic. In the most basic sense, that's what every firewall does. Okay, and then network address translation, almost every firewall does that as well. I don't consider that a requirement to be a firewall, but every firewall does it. All right, not going to spend too much time on this, a little bit of history. First firewall, Gen 1, was by Digital Equipment Corporation in '89. Then we've got a Gen 2 in '91, AT&T Labs. So the first one was just packet filtering, access lists, allow and deny rules, right? It had no intelligence. It's what's your source IP, what's your destination IP, are you allowed? So 1991, that's the first stateful firewall. So it's making decisions based on the state of the session. So it's looking at the traffic and it has to have a session table. Are you done talking? Did you initiate? So once you've initiated it, it allows the traffic coming back. So packet filtering and proxy connections combined into one appliance, that's 93. And then 94, Checkpoint came on the scene. We'll talk about them. They're definitely a leader in the Gartner Magic Quadrant. And they're a forerunner, a pioneer basically in firewall technology. So that was the first GUI, firewall with a GUI. Okay, continuing the timeline, 2004. So UTM is Unified Threat Management, and that's a little bit different than basically the next generation firewall. Unified Threat Management means you've got a collection of devices that are all working holistically together. So most next generation firewalls do include that dynamic, but that's separate and apart from, it's a precursor to basically next generation technology. So Palo Alto entered the market in 2018, significant advancement there. And then 2009, that's when Gartner basically explicitly defined the next generation firewall as a device that receives threat intelligence from outside of itself. And then today, next generation firewalls are merging into the cloud, and we'll talk about that. So what is a firewall? Is it a switch, a router, a server, a wireless access point? Well, the answer is it could be any of those. You know, all those technologies are merging together. It depends what it does. All right, here's your grandfather's firewall. Maybe. Depends how young your grandfather is, I suppose. This is a medium-sized corporation. You've got your protected network, perhaps at your data center. Perhaps you've got a satellite office with a second firewall. They're connected by IPsec. They're not really, you manage them independently, the two different interfaces. And then you've got remote users, perhaps, which are doing SSL VPN. It's got firewall rules, allow and deny. There you go. Up a few years ago, that kind of summed up most firewalls in the corporate environment. And then you might have a DMZ. And then if you're a little more advanced, maybe you're collecting your logs to some Splunk or SolarWinds or whatever, doing some analysis there. But most every firewall in the market that a business might buy will meet this definition, will perform these functions. Okay, so let's talk about next generation enterprise firewalls. So starting with the same thing here, and let's add unified security fabric. So now all the things in orange, those are basically communicating each other, and they're kind of the same cluster of devices. Meaning you log into one device, and you can manage all of those systems from one interface. And they're talking to each other. Okay, that's kind of cool. So now we've got the threat intelligence. So we talked about that. Maybe that's the vendor, the company that sold me the firewall. So it's got a constant feed of data coming into that firewall, which actually the entire security fabric benefits from. So if new threats are coming out, 0 day, I got that protection. Okay, so blue here, we got third-party data feeds. So we'll talk about the vulnerability databases that aren't necessarily part of my vendor's offering. Maybe I want to pull in data from CVE, internal endpoint agent integration. So what's happening here is more of the intelligent devices in your network are basically being tied into that security fabric. So your Windows computers, your Linux, your Android, your iPhones, they are basically controlled by this unified security fabric. Finally, we've got the remote endpoint agent integration. So it's the same concept as we have here for internal agents, but these users, maybe they're out at Starbucks. Maybe they're in Tacoma, Washington, visiting their family. Well, they're going to VPN into the environment, but they're still going to need that protection. We don't want them to be, exposed just because they're not on premise. So they can be tied in and managed from this unified security fabric. So finally, in addition to this very basic firewall allow and deny list, we now have IDS IPS. So that's intrusion detection, intrusion prevention. So historically, those would be separate devices that you buy that complement your security infrastructure. Now those systems are being collapsed into either the same physical appliance or the unified security fabric. So for most of these vendors, you can still buy these as separate devices. You get your firewall, you get your IDS IPS, your different web filters, they can be separate boxes if you need to scale the performance. But a lot of them say, if you don't need the performance, you can collapse them into one box. It's been abstracted. Okay, IOC. So that's a little different than IDS, IPS. IOC is indication of compromise. So if you've been compromised, that asset is going to be behaving a little bit differently. It's going to be talking to a command and control center. So you're going to need a device that's going to detect that, alert you, and possibly even quarantine that system. So the nice thing is, if you've got your switches in your unified security fabric, well, guess what? It can say, I can see that that compromised system is on port 12. Let me just shut that off automatically, alert the administrator, and it's quarantined. So now it can't affect other systems. So you don't have to wait for an IT person to walk over and pull that jack. Okay, what else did we? Here we go. Unified management. So you need a single pane of glass to basically manage this whole thing. And that's a key differentiator for most of the companies we're going to talk about. Reporting analytics. That could be a different interface, but threat intelligence. Give me some history. An auditor shows up. They want to know, can you prove that XYZ happened on a certain date? Yeah, I can pull that report. I've got access to those logs and easy dashboards I can rely on. Certificate management. So most firewalls, next generation firewalls, will allow you to create digital certificates and push those out to your end users. So that means your firewall is now basically can act as a man in the middle. So normally that's something you'd expect from a threat standpoint. But this is a good thing. This lets you basically inspect that traffic. And we'll be talking about that in depth. So, and to that point, here is exactly where we're decrypting SSL and TLS traffic and any other encrypted protocols. If you've got to make policy decisions based not only on where things are going, but what is inside the packet, you need to have that unencrypted traffic. And then finally, this isn't a requirement, but most enterprise firewalls will play nice with a SIEM. So that's Security Information Event Management System. So, a good SIEM can run you $1 million after you've bought it and implemented it. But large companies, Bank of America, Wells Fargo, they have to have those systems in place so that they can determine if there's been a compromise, is some adversary moving laterally through their environment. We need to be able to detect that. Okay, so success versus failure. So if you're going to take on this project, implement a firewall, what are you going to need to have on your side so that you're best prepared? You want to avoid a preconceived notion of what is the best. I really push back on that. Define the general needs of the organization. Every need is different. And most large organizations have an invested infrastructure. You might already have some security tools in place. Well, it may not make sense to rip and replace everything. There's a cost to that. If you've got a vendor that meets your criteria and plays nice with your existing infrastructure, that might be the better bet for you. Implementing a SWOT, so strength, weakness, opportunity, and threat chart. How many people here have done a SWOT analysis? Okay, awesome. It's a good exercise, and will kind of help you navigate the questions as far as how are you going to approach that decision-making process. So risk management, at the end of the day, that should always be part of your measure of success. How are you measuring risk? How are you managing risk? Any compliance program will help you do that. Budget, obviously that's a big factor. So measure and manage your TCO. It's not about what the quote says at the bottom from the vendor when you buy your firewall and after your implementation. What's it going to cost to own the solution day to day, train your staff, pay them to manage it, and dealing with incident responses. You've got to look at that over multiple years. On average, that's your total cost of ownership. So risk visibility. It's okay to have risk. You just need to know what it is so you can decide if you're going to accept it, remediate against it, transfer it, or solve it. Incident response, we don't need to go through all these. Compliance program support, prospect for long-term vendor support. Is your vendor viable? Do they have a large market share? Are they going to be there when you need their support? community support, availability of skilled personnel. Is there a large ecosystem of skilled partners that can basically help you manage the solution if you can't do it yourself? Opportunity for a holistic solution. So we'll talk about that. And then, do I do it myself? Do I partner? Some of the same conversations the last speaker had on, do I build my own cloud, or go it alone, or use a partner? Okay. So we're going to do a little bit of a technical deep dive into network protocols here, but I think it's relevant as a foundation for talking about firewalls. So protocols are a set of standards to define communication between systems. And I mean, the analogy I use for lay people, if you go to a cocktail party and you start talking to somebody, guess what? You've engaged in a communication protocol. Hi, my name is John. You expect them to respond in a certain way. You do your dance. That's everybody's working as expected. You exchange information. Okay, so a little bit of history here. This is every major protocol, I won't say every, but some of the major ones, and the year that they basically were released and came on the scene. So we can see that TCP/IP was actually a standard in 1983, and then gradually, continually adopted since then. OSI was 84. So not fully implemented. We'll talk about all of those a little bit in depth. Protocols are old. These standards have been around a long time. All right, what a protocol is and is not. Protocols are typically defined packet headers and sequencing. So protocols standards talk about this stuff, the headers. They do not talk about this stuff, what's inside the packet. That can be anything that somebody decides to put in there. So that's your payload. So in some cases, an adversary can actually tunnel one type of traffic inside of another. And you won't really know that, and especially if the data is encrypted, unless you can decrypt it. Okay, governing bodies. A number of standard bodies here. Some of these acronyms might look familiar. IETF and IRTF, those are the bodies that basically control a lot of the TCP/IP standards. So, but the point being that there's a lot of different standard bodies that control protocols. Bluetooth is an example. We'll just take that. So those guys run TCP/IP. So the Bluetooth Special Interest Group, I didn't pick them for any special reason other than just as an example. But so Bluetooth is a technology we all kind of know. It's ubiquitous. We've got it on our phone. But you know, they have a dedicated staff, and they have 30,000 member companies. So that's not atypical. So all those companies basically either produce or consume or have to integrate with Bluetooth technology. So they want to have a say in what the draft standards are as they're evolving that technology. And they probably pay a fee, and they produce documents and oversee the qualification for new products and standards. And so here's a list of the companies that are involved in the Bluetooth Special Interest Group. No big deal. Again, no reason I picked them in any other group, just as an example. But you know, for Linux, TCP/IP is not really being actively developed right now. It's pretty much baked in. But a lot of the advances are kind of in higher level protocols and applications. So IETF, RTF, Internet Engineering Task Force. So their mission is basically control the standards of the internet. FTP, TCP/IP, any whole plethora of them. They are not their mission is not necessarily security, it's really interoperability. So security's on the radar, certainly, but that's kind of important to know that it's more functionality. Okay, we'll kind of breeze through this. IETF, RFC. RFC is a request for comment. So every time a protocol is going to change, or they have to solve a new problem, somebody will release a request for comment. So everybody can say, oh, that's a good idea, that's a bad idea, wait, this is the outcome. So you can see over time that has increased. So this doesn't necessarily dovetail the adoption of the internet, but it kind of shows the active development of protocols that control traffic on the internet. Proof of concept, internet draft, request for comment, draft implementation. So these are the stages that an RFC will go through until it's accepted. It becomes a reference implementation. And by that, so if I'm a vendor and I'm going to create a system that supports a protocol, I'm going to look for that reference implementation. It's telling me what I need to do to make sure that I have compatibility with that RFC. Proprietary enhancements. So that's always a bit of a challenge. So I'm a vendor and I want to differentiate my product from everybody else's. I might do some extra tricky stuff and say, hey, that's a feature. Well, that's all well and good, but there may be certain situations that now I've lost interoperability with other vendors that are adhering 100% to the RFC. Okay, IP, UDP. Very basic stuff. I'm a server, I listen on a port for a connection, client connects, initial packet goes back and forth, got a IP port combination, the packet identifies a session or active connection that firewalls use. So if I'm on firewall, I'm tracking those TCP/IP, those IP addresses, maintaining that session table. I know who's talking to who and whether that session is active or not. And that helps me make other policy decisions. Okay, basic stuff. Hopefully everybody here is pretty familiar with this. The 4 layers of the IP stack. Won't go into that in too much detail. A bit of history here. The OSI was meant to replace TCP/IP, but it didn't because basically the TCP/IP was so entrenched, and everybody was using it, and nobody really wanted to migrate to OSI. TCP/IP was good enough. All right, common IP ports. This is mainly relevant here because when you're creating rules for firewalls, you might think, okay, as long as I'm blocking port 22, I'm blocking all SSH traffic. No, maybe not. Really, these are just conventions. An application can pick up and send SSH traffic over any port. It's just these are the well-known ports. So again, if I'm creating a server that a lot of public systems are connecting to, I'm going to listen on port 80 because that's HTTP. And most browsers are going to try to talk to me on HTTP. So, and that's kind of a characteristic of most next generation firewalls. They don't assume that a given type of traffic is on a given port. All right, IP version 6. So that doesn't really change most of the TCP/IP stack. It's basically just the networking layer, and it basically expands the address range. So that's a bit of a challenge for scanning tools and firewalls. Everybody says that they support IPv6, but you'll discover it's not. They don't support everything about it. So that's a bit of a challenge in security. All right. We don't need to go to that. Well, this is probably worth mentioning. So as part of our tool set, we use Qualys to do vulnerability scans for our clients. And we have some clients that are using dual stack. They use IPv4, IPv6. And we scanned IPv4, no problem. And we said, look, we want to scan IPv6. And it turns out that the Qualys tool, that's not turned on by default, which I thought was kind of odd. So I had to call support, have them turn on that functionality. And then I said, well, I want to do a scan. And they said, well, you can't. You cannot scan IPv6. The address range is too large. What you have to do is identify every IPv4 system that you believe has an IPv6 address and map those in the Qualys tool. And then you can scan all the things that you believe to have IPv6. Like, well, I want you to tell me where IPv6 is. I don't want to have to tell you. So that definitely is a limitation of the fact that the address range is so large, but it's also a compromise. You have the tools don't really help you, and I know some very large companies in town that refuse to have IPv6 in their environment for that and other reasons. Okay, OSI Protocol Stack. I won't spend a lot of time on this. The only reason it's worth mentioning is how many people here have heard their security vendor say, oh, we support all 7 layers. All 7 of them. What 7 layers are they talking about? There's only 4 layers in TCP/IP, but they're talking about OSI, even though it's a reference standard and it's not real. So this is kind of abstraction, Once you get above layer 4, you're just talking about applications and you put them in those different buckets. So, all right. And then application, Presentation of session again. So here's the applications: Telnet, FTP, SMTP. TCP/IP is kind of a sloppy standard. It really only defines what happens at layer 4 and below. And then above here, you're just getting applications. So it's whatever the programmer wants to do. TCP/IP, OSI calls that the session, presentation, and application layer. Again, just when people are throwing those terms around, you know what they're talking about. Certainly not going to go through this. This is a poster from Network Associates. Basically, it shows all the communication, well, some of the major communication protocols. So this is TCP/IP family of protocols, but every block here is one or more RFC that define what that piece of software is supposed to do and how it communicates with the rest of the stack. And then red here, we have Novell NetWare. I assume nobody here is using that, probably. IBM's SNA protocol, ISO. This was never fully implemented. It's really a reference stack. DECnet, phase 5. That's kind of what I grew up on. XNS, AppleTalk, and Banyan Vines. And then down here, these are physical layer protocols. Anyway, the takeaway is protocols are complex. So, all right, network architectures. Briefly going to touch on this. So this is we see the physical topology. These are how the switches are connected. And then we see a logical topology. So VLAN 1 intersects multiple switches. So that's just the key takeaway being that the physical topology is not always the same as a logical topology, as we hopefully all know. So to represent this, I would need both a layer 2 diagram and a layer 3 diagram. And that comes into play when I'm trying to do my security design. What am I protecting? I'm not just worried about traffic between these two physical devices. I'm worried about traffic crossing these two or three different VLANs. Through this. Again, I'm a history buff. 71, this is the first believed internet diagram. So basically you had some research institutions and some educational. These were all connected by 56 kilobit lines. So Stanford, Rand Corp, Harvard. So this was the first TCP/IP implementation. 1980, this is just 9 years later. Pretty significant increase. We got satellite links out to Hawaii and then to London. But again, these are mostly 56K links. Usenet 1986, 6 years later. We started to get a global network. We got connections out to the Philippines, Southeast Asia, Europe. Internet in 2013. So I got this from Wired Magazine. So this only represents publicly addressable IP internet. With the Internet of Things, this number is actually quite a bit larger. Okay, encryption. So we've got to talk about encryption to get into the firewall and what it's doing and why. So Gartner anticipates that through 2019, more than 80% of enterprise web traffic will be encrypted. So what does that mean for a security engineer? So if they're going to make decisions, I've got to find a way to decrypt that traffic. And it might be encrypted using different encryption algorithms, different certificates. So I've got to have not only a firewall with the performance to decrypt it, with the capabilities to load those certificates and support all those different protocols. And so that's a good point, is most malicious software will communicate laterally or with its command and control system with encrypted traffic. Of course they're going to do that. They don't want to be caught. So if you do not have a firewall capable of decrypting that traffic, you're not going to be able to block or even detect that activity. Okay. And I was talking to somebody about this in the hallway, actually, the difference between asymmetric and symmetric. So asymmetric is if you're doing PGP, or I've got a private key, a public key. I'll give you my public key. You can encrypt traffic for me. You send me a file. It's an attachment. Anybody can see it, but only I can decrypt it because I've got that private key. So that's asymmetric. Symmetric is when you've got a VPN session. So a firewall says, okay, it can be SSL VPN. I'm going to make a connection to another firewall. They negotiate that key in their phase 1 connection. and then basically they establish another secure connection using that initially negotiated key. So even if somebody's observing that traffic channel, they can't decrypt it. Certificates are separate than encryption, but it uses encryption, but it might be used to basically certify that you are who you say you are, to authenticate yourself and digitally sign a piece of information. So self-signed certificates. How many people here have self-signed certificates on a device in their network? Okay, anybody that's not raising their hand is lying. I mean, by default, if you want to have HTTPS management on a device, it's going to be self-signed unless you pay for that public certificate that is authoritated to a root authority. And that can get expensive unless you do a wildcard. So encryption, salting, and hashing, those are different things. We're not going to get into that right now. So the need for encryption, secure web for financial, for privacy, client-server channels, VPN, digital signatures, encryption at rest, encryption at transit. So encryption is a way of life. We have to have it. It's only going to become more important. Apologize for going on the rabbit hole here, but these are, when you're setting up encryption, you kind of need to know the landscape of standards here. So DES and 3DS, which is not as insecure. So the ones in red, basically you should not be using. RSA is asymmetric, so that might be used in a PGP if you're encrypting a file with a public-private key. But the rest of them are basically symmetric. So if you're doing real-time encryption, these are the algorithms under the hood that might be used. SHA, Blowfish, AES. All right. Encryption DES, got a thumbs down, going to go into that. It can be cracked in a moderately reasonable amount of time with enough computing power. 3DES, it's kind of an enhanced version of it, but even so, it's pretty slow unless you've got dedicated hardware that's that encryption. AES really is what you should be using, if at all possible. It's got a number of different options for keys. 120 bits is already very unbreakable. Well, until quantum computing maybe gets some traction here. Encryption SHA-2. So SHA-0 and 1 have been proven to be insecure. SHA-2 and above are still good. And then RSA. So that isn't so much easy for VPNs. Again, that's for file public-private key encryption. Okay, so this is kind of a distinction that's important, but most people don't make it. So these are secure protocols. These are not encryption algorithms, meaning that each one of these communication protocols can decide to use one of those encryption algorithms. So you can have what you believe to be a secure communication protocol, but it might be using an insecure algorithm. So these are matched up. Anyway, so these are typical protocols that require encryption that you might be running into in your corporate network. Okay, kind of getting the weeds here. So I pulled this from one of our clients, Apache, web server, SSH config files. So basically, two systems might negotiate what encryption algorithms are you capable of performing, and which ones am I capable of performing? Okay, great. Now let's just go through from the most desirable down to whatever we have in common, and then settle on the most secure. So in this case, this web servers, it is specifying what the sequence are for that negotiation. Encryption Cipher, so Microsoft's got to play, it's in the same swimming pool as the rest of us, so it's got to allow you to modify those ciphers. So these are links where you can control your Microsoft server, tell it which ciphers you allow it to use. OpenSSH session using verbose. So I'm a bit of a Linux guy. So here I'm basically connecting to a Linux machine. It's target, -VV, so it's 2 levels of verbosity. And I've taken a segment here, so here it's showing what the client algorithm is saying, look, I can use this curve 25519 SHA-256. The server host is coming back and saying, It can use a slightly different algorithm, but it's still compatible with that SHA. So, and then later in the sequence, these are the ones they agree. So even though they're using two different algorithms, they're compatible. We'll talk about the threat landscape. Okay, the European Union Agency for Network and Information Security, ENISA. So this actually is a pretty darn good report. It's about 333 pages. I would definitely recommend looking at it. So it breaks down the threat landscape for last year in all these different categories. It is very interesting reading. Not only what's going on, but where the trends are headed. So very informative for somebody who's kind of planning their security strategy. Okay, vulnerability databases. Compromises, those vulnerabilities are basically tracked by either NIST or CVE, run by MITRE. And actually, NIST and CVE work closely together. If something gets in the CVE vulnerability repository, it is synced to NIST. So there's a lot of cooperation there. And then we all know Microsoft Patch Tuesday. And then ExploitDB is another variation. And then Circle is basically an interface to search the CVE database. And there's other commercial databases, Shandon Data Services. Here's a CVE article that I just pulled at random. So this is a vulnerability. What's it for? It's some sound driver. Before version 2.29 allows a local attacker to increase privileges to the Windows registry. Okay, so it tells how it works, what the threat vector is, a number of factors. So it's all public information in this database. NVD Data Feeds. They can come in from JSON, XML, RSS. You can get vulnerability translation feeds, vendor comments, CPE dictionary. CPE is customer premise equipment. That's kind of a phone company term, but talks about the different equipment that may be subject to those vulnerabilities, and then other information relating to vulnerabilities. So let's get into CVE scoring, which is relevant to when we talk about our firewalls and how they're going to measure a threat. So all these vulnerabilities are given a score using the common vulnerability scoring system. Now that's subjective. What one vulnerability is for one organization may not be as large an impact for another. So there's ways to take the default scoring and then modify it for your situation. And here's how you do it. So we basically have a base metric group. So you'll score your vulnerability or your potential compromise basically on the attack vector. You know, do they come in through, do they need public access to a given web server? If so, then if that web server is internally, they don't have a direct vector to get into that. So you might give it a different score. Attack complexity, the privileges required, user interaction, and then impact. What is the impact of a potential compromise there? Are they going to take confidential information? Do they affect the integrity of my data? Or are they going to affect availability? Do a denial of service attack, what have you. Temporal metrics, how, if it's a 0 day and nobody's had time to basically write a execution, a compromise, the code for that's not very mature. Over time, people will put together a hacking kit that's been tested, and now the vulnerability is going to become more exploitable over time. Anyway, so we don't need to go through all these, but environmental metric group. So this is where you put in your specific modified base metrics and the things that you feel are specific to your organization. So you'll override what the default CVE scoring is. So there used to be, well, the old one is 2.0. Now this CVS scoring system 3.0 is what's being adopted. So after you go through that exercise, you'll basically get a score. None, low, medium, high, and critical. So the challenge here is if you're an executive, like, let's just deal with all the high vulnerabilities. Well, if you haven't gone through the scoring exercise correctly, you maybe have a low score for a vulnerability, but it could greatly impact a system that's critical to your business. So it's very important that you don't, be lackadaisical about how you approach this. All right. All right, we won't go through this. So this is the technical details. Basically, when you do that scoring, you come up with these mnemonics or these codes, and they will then go into the CVE Vector String. So CVSS 3.1, so it's using the 3.1 scoring system. So all these acronyms basically indicate which of those, the vectors, the impact, the availability, the maturity of the code. It's basically mnemonics to indicate what are the hit points on that matrix as far as the vulnerability. And this is a lot of rich metadata that firewalls or other security management systems can ingest and use. Okay.
Where did you talk to this? Is it into your IDU side display? That's when you talk with the CVE and the CVS stuff? Or where do you use it?
So this can be ingested by your, basically a SIEM, Security Information Event Management System. So it depends on how intelligent your IDS, IPS system is. But mainly a security analyst would use this, or an automated system. If you've got to make, so for example, how many people here are aware of Tenable? Okay, so I actually know one of the principal engineers at Tenable, and he was mentioning that they have a challenge. So they'll do the vulnerability scan, and they'll get the CVE score, but they want to do an automated way to report the risk to their clients. Because it's very arduous to go through the manual scoring part of this. They just want to use the automated one. So for example, they've decided to, if it's a MySQL database, they will give that an artificially high score, just because they assume that's a repository of information that's probably important to the customer. Well, if that's a test dev environment, that's a false assumption. It shouldn't be scored high on the CVE score. So, so to answer your question, it is a number of systems. Usually it's a vulnerability scanning where they produce that the risk portion of the report. That's what's going to be utilize the CVE scoring system. Okay, how many people here are familiar with the Mary Meeker report? So this is fascinating. So she's a former partner of Klein & Perkins, now with Bond Capital. So she's been doing this for a number of years. So it's basically over a 600-page report that talks about all the dynamics of the internet. It's not necessarily focused on security, but it'll talk about security trends and advertising and utilization. So she does, and it's available at that link. Again, that'll be a PDF you can get from Mark or the ISC Squared website. But so you can see the percent of users using selected platforms. We're seeing. So the reason this is relevant, you can rest assured that if you have a corporate environment and you are not filtering the type of traffic and where people are going, they're going to Facebook at their desk. Of course they are. WhatsApp or all this stuff. In fact, you got a faster internet at work than they do at home. That's probably where they're doing most of their browsing. And then here's the trend for the types of encryption that's occurring on those platforms. So iMessage, WhatsApp. So they enforce default end-to-end encryption. You can get encryption for Instagram, Facebook Messenger, Gmail, and then no encryption for Twitter or WeChat. But the trend is obviously obvious. Everything's going to become encrypted that is in any way sensitive. Okay, we're going to breeze through this. Packet filtering firewalls, again, we talked about that. It's just source address, destination address, allow or deny. That's the first generation. Circuit level gateways, now it's looking at the session. So anything in blue is basically what's different from the slide before. Once you establish a session, if it's established from the inside, I will let the return traffic come through. So it's looking at the stateful session of the circuit level. So this is a combination of two, stateful packet inspection and policy. So proxy firewalls. So a proxy basically is saying, look, instead of you connecting directly to your endpoint destination, you're going to connect to me. I'm going to pretend to be the server you're trying to talk to, and then I'll make the connection to the system you're trying to pull the data from. So I'm the arbitrator between the client and the server. Okay, UTM Firewall, we touched briefly on this. The biggest differentiator is that they act as a combination of network IPS with deep packet inspection. And they have multiple devices that are all controlled in a fabric. Okay, now we're into hopefully the juicy stuff. Next generation firewalls. So Gartner defines it as a deep packet inspection that moves beyond port protocol and adds application level inspection, intrusion prevention, and bringing intelligence from outside the firewall. So that's key. It's not just the box sitting in your IT room. It is all the intelligence it's ingesting from the vendor on a daily basis, those threat feeds. Okay, well, this is the same slide we saw before. So just to review, there's our security fabric, our threat intelligence, third-party data feeds, endpoint integration, remote endpoints, IDS, IPS, IOC, heuristic analysis. We didn't really talk about that. That should actually be DLP, not DSP, and SD-WAN. But unified management, reporting analytics, security management, SSL, TLS decryption, and a potentially a SIEM. Okay. So a firewall can have any or all of the following features. We kind of touched on a lot of these. Frequent and real-time threat signature, push from a centralized source, integrated IDS, IPS, that's focused on both vulnerability and threat-facing signatures. Web URL filtering services tightly integrated. So all of these traditionally have been separate devices. You might get a separate Barracuda appliance that does web filtering. You can still get these in separate devices, but they're all kind of the same unified fabric in this context. Botnet detection to known command and control systems, replacement for your edge router. Most firewalls will now do BGP routing, OSPF. They can replace your router. Full protocol stack visibility with application identification. They'll know if something's talking HTTPS, but it's really sending FTP data. They'll look inside the packet data stream to know what it's sending. Ability to generate, issue, push out security certificates. Able to enforce policy independent of port protocol. So that's key. Integration with directory services. So if I want to do policy based on user groups in my Active Directory, it's got to talk to Active Directory. It's got to know who's in which groups. It usually involves an agent running a domain controller that's talking to my firewall. Ability to map user accounts to systems and network activity. So it can make suggestions based on IPS activity. So if I've got a security analyst or a network security administrator, hopefully my firewall is telling them, hey, you need to look at this. So it may control and take action on network infrastructure. So again, if I've got a rogue device on a switch port and it's controlling that switch, it can shut down that port, isolate that system. So on a trust metric level, not absolute trust. So this is key. So we talked about, I don't like the term trusted network, because no network really should be trusted. And we're getting away from absolute trust and security. Everything is assessed as far as a trust level. And that is going to be the new reality. So heuristic analysis dynamically modifies trust level based on network traffic. And we've got some pictures of some firewall interfaces and how they do that. So collapse security management into many devices, all into one interface. Continuing the list. On subscription expiration, traditional firewalls usually continue to work. So full feature published API is application programmer interface. So if you have other third-party systems you want to integrate, you want to be able to pull data and interact with it. Ability to ingest third-party information, feeds for future expansion. We talked about that. The NVD databases, CVE, from NIST, you want to pull those and make decisions in your IDS based on that. Ability to cluster for high availability. So that's in large environments. If you've got a terabyte of data, you probably can't push all that data through one box. You're going to need a chassis-based solution or a cluster. Inline configuration allowing transparent network implementation. That's a bump in the wire. So bolt-on data analytics showing security baseline and anomalies. tighter integration with SIEM offerings by the same vendor. Trending features, machine learning. So machine learning is a big part of security these days. What is the baseline? What is usual? You need to run your firewall, let it decide, determine what normal is. Okay, just to review. Packet filtering, stateful packet inspection, proxy UTM, next generation firewalls, kind of the top of the pyramid. So the challenges. So integrated inspection pipeline, all the capabilities bolted into separate components. This can be a challenge for performance and reporting and data correlation. So if, early vendors, they just kind of threw together different pieces of software, it wasn't really tightly integrated. Hey, we check all the boxes. Well, if it's not well integrated and has high performance, you're not going to get the result you want. Throughput, so same thing. Ease of use. If you've got different interfaces that are just clunky and hard to navigate, that is an inhibitor to responding in real time to security incidences. You want something that's elegant and allows you to drill down and get the information quickly. So decryption, SSL, TLS, SFTP, that's a must. I would not put a firewall in place that did not have the ability to decrypt traffic. So lack of support for non-TCP IP protocols or IPv6. Not going to get into that, but you need to know what protocols are running in your environment, and if your firewall can't police them, you should probably turn those protocols off. OSI 7 layers, covered that. So risk is where you aren't looking. TCP IP is probably the mother lode of all traffic in your network, but there's other out-of-band communication. We recently had a presentation by, all right, firewall deployment models, hardware, software, hypervisor, mobile container, get into all that. VMware is noteworthy here. So they've got some firewall technology. I would not call this a next generation firewall, but it is, so you can do firewall policies on a guest VM, and you migrate that VM to another host. Those firewall policies are going to follow that VM. That's kind of innovative, and that's much needed, flexibility and security dynamics that they're addressing that need in the data center. Okay, I think we just covered all on one page. Okay, Gartner report for 2018. So they mentioned that they want to get away from the term next generation firewall just because it's such a fuzzy term. Vendors are claiming it's debatable what it really means, as you can probably get the gist of that. So enterprise firewall is what they refer to. So this is basically a summary of what an enterprise firewall is, the direction it's going, the takeaways. So at the end of the day, it's really about policy orchestration. I don't go into, if I have 5 devices across my geographic area, I don't log into each of those 5 devices and set up the policies. I'm doing it in a central console, pushing out those policies. Okay, so here we go. This comes straight from Gartner. This is the Gartner Magic Quadrant. On the top right, we basically have the leaders, which have the ability to execute and completeness of vision. Now, I will say that this is from 2018. So everything here is subject to change. And at the end of this, so I've got information from Gartner, and I've also got information from NSS Labs, which we're going to go through momentarily. NSS Labs gave me their 2018 report, and they wanted to give me their 2019 report, but it doesn't come out until tomorrow. So, got the contact information. If you want to get that, they'd love to talk to you. But so we're going to touch on Cisco, Fortinet, Palo Alto, and Check Point. Those are the 4 leaders in the Gartner Magic Quadrant. So Check Point. Again, we're not endorsing any product here. I'm just pulling some information straight from the website, from what I've known. Try to keep it objective. But at a high level, this is what they are, their complement of the ecosphere of services within their next generation firewall offering. So we see Sandblast. So this is similar to Fortinet's Sandbox. Here are their strengths, according to Gartner, 2018. Simplified all-inclusive, large enterprise pricing. So, I get Gartner here is really trying to take a very high-level view on, if you're a large organization, it's not just about the technology. Does that partner what is the total cost of ownership, the budget, the price point, the financial viability. There's a lot of factors. So those are all important. They have a solution to do it price user. So that's kind of innovative. And I think that's a direction the industry is going. Because it's so complex. If you've got 10,000 people in your organization, how many boxes do I need here, there, my licensing model? It can be overwhelming. But if you just, hey, give me a total solution, price per user, that's easy. I can budget for that. Offers third-party threat intelligence feeds. We talked about that. That's a common. So it's not just the threat intelligence from Checkpoint. You can tie in external third-party feeds. A strong ecosystem of partners. So there we go. Key verticals that got focused on SCADA, MedFin, government, global company. So their cautions, not always perceived as an innovator. They're challenged by Fortinet and Palo Alto. The R80 release cycle, so that's their software version, is noted as lagging. I don't know if all this is relevant today, but correct product sizing key for performance under high load. So that's probably noteworthy. If your salesperson says you can probably get by with Model X, and that's in your budget, they know they can sell it to you, and they do, and then you realize, well, guess what? Your organization is going to grow in the next 3 to 5 years, which should be your planning cycle for doing a firewall. You're going to hit that performance limit. You really should be planning 3 to 5 years out and getting something a little bigger than you need. Otherwise, you're going to hit that performance ceiling. Quality service doesn't work with multiple WAN lengths, which was interesting. Again, all this might be corrected. Could be a year old. Decryption for FTPS and SSH missing. That seemed odd to me. So they do encryption for AES and TLS, but not FTP and SSH. In customer surveys, they might get mediocre support, but with higher support plans, you get that top shelf support. Something to be aware of. So Cisco Firepower. I'm a Cisco guy from back in the day. Maybe most network guys are, but haven't worked with Firepower. I don't see them much in the security landscape. So product execution, Cisco Talus. So that is their the group in the cloud that's doing the threat intelligence and sending the feeds down to the device. So they've got a lot of partnerships, integrated DDoS mitigation. So that was talked about by the previous speaker. DDoS is distributed denial of service attacks. That's a real thing. That's going on all the time. So you're going to need a device that basically can mitigate that by selectively dropping packets, but not so much that you fully lose your connection. So they've got some broad-ranging ELAs or end-user license agreements. So those can be favorable to large organizations. Machine learning capabilities. Again, I'm dubious of that. That's still an immature technology in my mind. So product lines crossover. Most people remember the Cisco ASAs. So this is a little goofy. You can get Firepower services on top of your existing ASA if it's a new enough model. Or you can just go and get the Firepower chassis platform. So then they've acquired Meraki a few years ago. So that's a completely separate company that has firewalls as well. So it's a little fuzzy as far as their product lineup and a lot of overlap. What are they suggesting you go with? So the user interface sprawl, they have a lot of different UIs depending on what you're trying to manage. I've used ADSM to manage Cisco ASAs. Then I have the FDM, Firepower, forget what that is. So it is a significant learning curve. Gartner mentioned that if you're going to migrate from a Cisco ASA to a Firepower, it's the same learning curve as if you just went to an entirely different product. There isn't a lot of crossover there. Something to be aware of. And no SSL VPN functionality. Okay, Fortinet. I've got a fair amount of experience with Fortinet. We're a Fortinet shop for the most part, but try not to give them any favorable coverage here. So this is taken straight from some of their product literature. So network security, multi-cloud security, security, email, web app, secure unified access, advanced threat protection, management analytics. So those are kind of their stacks. This is kind of the product lineup. I could talk in depth about most of these. The point is that these are all very much part of the same unified security fabric. They're, for the most part, managed by the FortiGate console. You can manage all your switches, your Wi-Fi. Now they've got a separate management platform for FortiAnalyzer and then your FortiManager. So FortiAnalyzer, this is where you're getting your threat analytics, all your reporting data. FortiManager, here's where you're doing centralized policy and you're pushing that down to all your firewalls in your domain. And they can be geographically dispersed, they can be the same location, different models, doesn't matter. And we've done that for a few clients. Okay, so they're often shortlisted by enterprise clients for security. So they're on the radar for enterprise clients. And some of that, I think, has to do with their price point. They're competitive. And they check a lot of the boxes for that people need for next generation firewalls. They support for IBM and Oracle public information as a service. So one thing the gentleman in the last presentation didn't talk about was there's a rich ecosystem for third-party vendor product. Go into AWS, I can spin up a Fortinet. I can spin up a checkpoint as a virtual software appliance. So people complain about AWS, oh, it's not secure. I can add this high-powered security on top of my public cloud solution. So that's something to be aware of. So in addition, they actually offer those in IBM, SoftLayer, and Oracle's cloud. And so there we go. Caution, still emerging as an enterprise player and competing with more established providers. You know, Checkpoint, Palo Alto, however, I know when some of our clients kind of warmed up on Fortinet, some of our clients are actually banks. And the Federal Reserve has something called FedLine. So any wire transfer over $100,000 has to go through this special thing called FedLine. So the feds will put a Cisco device in your bank, and then that goes to the Federal Reserve. So one week we came in and the Federal Reserve replaced all their Cisco with Fortinet. So that's when the bank said, okay, you've been talking about Fortinet for a while, I guess the Federal Reserve just converted. So, and that's one of the reasons that as a managed service security service provider, we like to put it in there. And if you go with a full complement of services, they can start to get up there, but you can get Fortinet with the full UTM suite at a pretty reasonable price. So, Palo Alto, again, I've taken this directly from their website. Don't have direct experience with them. But from what I have researched, they have a very innovative interface where you can drill down, see what applications are happening in your data stream, and drill down into those protocols and see where those threats are. So this looks like a pretty clean dashboard, so I was impressed with this. And they've got some big boxes that can top out at 10 gig of IPS activity, 10 gigabits per second. So their 2018 product refresh with more competitive price performance ratios. They've got a global Protect Cloud service. I've talked to them about this. So they are strictly a security company. They don't do routers, they don't do toasters, they just do security. That is their singular focus. So that is a plus in their column. Well-defined roadmap, increase in ELA, again, and license agreements. So if you want to buy their entire solution, they have a very simplified pricing model with that ELA. Application Command Center includes full visibility. I believe that's the diagram we saw earlier. Advanced UI tools, scores high with customers for overall satisfaction, and improved TLS encryption. So they said that was a weakness earlier, but with the latest software release and the new hardware, they can do real-time TLS encryption at a very high level. So price is frequently cited as an inhibitor Quality support may vary by region. Quality of major version software release is lacking. So they said that on the, when a major release comes out, it might be a little buggy. There's been a history of that. So that's kind of disappointing to hear. Hopefully they'll be testing that. But then that's hopefully on you. You can decide when you jump on that major release cycle. The number of max virtual appliances lower than competitors. So I'll touch on what that means. So in the Fortinet world, they call those a VDOM, virtual domain. So I can have a large firewall and I can break that up into basically logical firewalls. So I could say, look, I've got a group of administrators. You can manage what's happening over here between these subnets. Another administrator can manage what's your policies, and all that's running on the same firewall, but it's basically like VMware. I'm creating virtual guest firewalls that can be managed separately. So those are, the number of those are limited to Palo Alto. Okay, so this is actually taken from the product lineup for Fortinet. So basically these are all the features that would be common in a next generation firewall offering, and kind of what Fortinet product solves that problem, and whether it's integrated into, so firewalls, you've got physical, virtual, the VDOMs, we just mentioned that, those are the virtual domains. Proxy, Wi-Fi, sandbox. So sandbox is worth touching on. Most firewall vendors have this where, let's say an email is coming in with an attachment, and you cannot make a security decision whether that's safe or not. So what it can do is shunt that off to a protected area in memory and pretend to open the attachment as if the same dynamic the client was. So if that's a malicious payload and it's waiting to trigger until it's been opened, that's what will occur in that quarantined environment. And that will determine the behavior of that payload and whether it's safe or not, and then deliver it to the user or not, or keep it quarantined. So that it can delay the user experience where my email is taking longer to get to me, or whatever information I'm waiting for. But if you've got a lot of malicious payloads in your traffic stream, it might be important to you. Okay, Fortigate is an example. Again, not trying to play favorites here, but this is their user interface. I think it's worth going through quickly. So you can kind of see that they've got, so the FortiView. So that's kind of, we talked about the FortiAnalyzer. This is the light version of that analysis that's built into every firewall. So you can kind of see a lot of things about your traffic stream just from within your firewall. Endpoint vulnerability, threat map, so we'll look at that. Security fabric, you can look at the physical topology, logical topology. We talked about the difference between layer 2 and layer 3. All your Wi-Fi devices can all be managed, again, directly from your firewall. And then your security profiles. Intrusion prevention, data leak prevention, web application, compliance, and a proxy and SSL, SSH inspection. And it integrates with that, your directory services, in this case LDAP. You can monitor for rogue devices, and then logging and reporting. Here's a device map from a Fortinet. So basically, here's all the IP addresses that are talking. And then these are all my different VLANs in this case. And so it's doing a bubble chart based on the amount of traffic coming in and out of that device. So it just gives me a high-level view as a network administrator, who's talking to who and how much data is flowing. Okay, so let's go to the same screen, except I've changed the drop-down to say, hey, show me the threat score. So now it's showing me the same devices, but the size of the bubbles are the perceived threat of that endpoint. So now I kind of know, hey, where should my focus be? So in this case, this DC01, it's got a threat score of 40. And I can drill down and it'll tell me why. Just based on the number of sessions, or depending on what services it's running, could be any number of things. Okay, finally, so this is just a small example. We have a SIEM. We're using Elasticsearch. We're ingesting a lot of firewall log data and data from Windows event logs, and then we display it on these dashboards. So this gives us our security intelligence for our clients, kind of knows who's talking to who, what ports, Anyway, so that's an example where we've developed our own threat intelligence to supplement what we're getting from the vendor product. So Gartner Magic Quadrant 2017. So this is the year before. Again, Cisco, Fortinet, Palo Alto, Checkpoint. Same players here. This one's for SMB. So this is small to medium-sized firewalls. Fortinet's a leader there. All right, so NSS Labs, Next Generation Comparative Report. So this, basically they did a report, and I can show it to you. I can't make it available to you, unfortunately, because of the license requirements, but we can look at some of the juicy data here. These are basically who they've run their bake-off on, and what product and version was tested. Okay, these are the vendors. This is the block rate, what the percentage of vulnerabilities or malicious payloads that they blocked. The percent of evasions that did not get through. Stability and reliability. So the basically security effectiveness. So Checkpoint, I was surprised by this score. Again, this is a year old, so they've got a new one coming out just in the next few days. And I've been told Cisco chose not to participate in NS Labs 2019 bake-off. So that might be telling. Exploit block by rate by year. So this is kind of interesting. And so it's not just about what are your zero-day threats. There may be vulnerabilities that might be 5 years old. And is your firewall still holding those signatures and blocking that traffic? If it's not because it doesn't think those are a threat anymore, well, that's a problem. If you pull that old computer out of a closet and put that on your network, well, it's that threat won't be blocked if your firewall isn't retaining those legacy signatures. So in this case, we've got items back from 2010, 2009 that we're not getting 100% blockage on. Okay, so this is evasion resistance, and I've got the text. I can actually pull it up if we're interested. So for the most part, everybody's passing. We've got a few fails here. Attack on non-standard ports with Barracuda. RPC fragmentation by Checkpoint. HTTP evasions. So here we go. So this is overall security effectiveness. Again, as measured by NSS Labs for 2018. So I would caution that this is only part of the story, because if I'm evaluating a vendor, it's not just about their percentage on this chart. I also place a lot of value in how well do their user interfaces work together. How well is it easy to add to administer the system? Those should all be factors when you're looking at a solution. The 2019 NSS Lab report is due out tomorrow. No coincidence, coincidentally. And they're saying that it's got quite a few surprises. So if you're interested, this is the gentleman that would love to talk to you if you're interested in purchasing that report. And again, David was kind enough to provide this report for free for this presentation. So many of these systems have such a significant complement of features. Almost nobody's using all the features. And so that's why I would recommend, even if you are going it alone with implementing a large security solution, you should have a partner, whether that's external or the vendor themselves, that can tell you how to best use that tool in your environment. Thank you. Anything else? All right, well, that's it. Thank you for your time.
Thank you, John.